Okay, so today's video is going to be a little different than usual. We're going to do what is known as a circuit integrity test. We're going to test the circuit on the electrical side, and we're going to test the circuit as far as operation goes. So what we're looking at is a 98 Pontiac Transport 3.4. Problem is cooling fans are not coming on, and I've changed the coolant temp sensor twice. We got a little bit of a leak going on right there. We're getting that addressed. So that wire right here that's got the yellow on it, that's going to be our coolant temp wire, and we're going to test it. We're going to test it for integrity by hooking the 504 up to it and make sure that we got our 5-volt reference when we turn our key on. Then we're going to hook the sensor to it, and we're going to put it in a cup of water. Of course, you can use a cup of antifreeze if you prefer. And we're going to heat the cup up, and we're going to make sure that the dashboard responds properly. Because the other thing is her dashboard temperature gauge bottoms out to 260 when it shouldn't be bottoming out at all. So if you've caught all that, then you're ready to go. So we're going to start off by going over the wiring real quick so that you know what we're doing. So this has 3 wires on it. Zoom in there so you can see where we're at here. Alright, so you got a green wire, a yellow wire, and a black wire. The green wire is your wire to your gauge. Yellow wire is your 5-volt reference, and your black wire is ground. So we're going to start off by testing ground. So I'm going to get that set up for that, and then I'll be right back. Okay, when your meter's plugged in correctly, that is what it should look like. We got T-pins. We're using our alligator ends on our 504, and we've got the black lead into the ground lead, which is the black wire. The red one is in the green lead. No, I'm sorry, yellow lead. That is our 5-volt reference. So when I turn the key on, that should read 5 volts. So stand by. And we're reading battery voltage. That's interesting. Okay, so I'm going to turn that off, and I'm going to hook it to the green wire, and we're going to see what we get off the green wire. Alright, so we're going to hook it to the green wire. I was expecting 5-volt reference, but maybe we're on the wrong lead for that one. Alright, so now we're on the yellow wire, and of course we're zeroed out. So yellow wire should be our signal wire. So we were on the green one before, I think. Yeah, we were on the yellow one, or the green one. That's why we were getting battery voltage. That's our signal wire to our gauge. So this one should give us 5-volt reference. Stand by. And we have our 5-volt reference. So what this tells me is that the circuit's good going to the PCM, and we don't need to look for any grounding problems, chafed wiring, any funny stuff like that. So now we're going to get to the science part of it. We're going to connect the wire back to the switch. We're going to stick the switch in a cup of water. It's a metal cup so we can heat it. We're going to use a propane torch, but you could use butane if you prefer. We're going to warm the cup. Okay, so I got you looking at the scan tool. Bottom temperature says 75 degrees. That's the ambient air temperature right now outside. The coolant temp sensor is reading within a degree or 2 of that. Okay, our gauge is still bottomed at 100 or less, so that's good. We can't get a cup down in there, so what I'm going to do is I'm going to take the torch and just kind of braze over the top of it a couple times. We're going to look at this number here, and then we're also going to check the gauge to make sure the gauge is functioning. So let's get started. Normally, if you had a cup or a container, a metal one where you can warm it up, you can do this with water. But I'm not going to put too much on it because you can actually damage the sensor doing it this way. That's why we're going to do brazings. If I can get my torch to light. Alright, we're up to 97, 99, 100. Our gauge is not moving yet. So we're going to hold it at 108. Alright, we're going to go ahead and wave it some more. It's going up to 113, 115, 117. Our gauge is not moving. Okay, that gauge should be off of 100 by now. Alright, let's keep going. 120. I'm only doing this in short bursts. At 136. Our gauge is still pegged at 0. Alright. 147. We should be somewhere, that gauge should be working. It's not moving. I'm kind of concerned here at this point. Whoa. It does that sometimes, and it comes up with water. Alright, we're having technical difficulties here, so let's see, where's our temperature sitting at? 151. And our gauge is pegged. Okay, so our gauge is pegged at 151 degrees. We're going to let it cool down a minute while I relight my torch. We're going to see about what temperature it has to be before that gauge goes nuts. Because this, I can tell the customer that when the gauge hits X amount, that's how warm it is. So we're going to let it cool down, and then I'll let you know when the dash gauge goes nuts and stops going nuts. Then we're going to move the sensor to a safer area under the hood, and we're going to get it up to about 212 degrees, which is boiling point. We're going to see if we can get the cooling fans to activate. If we can get the cooling fans to activate at 212, then the switch is good and we can go ahead and figure out what else we got to do. If we can't and we get this thing up to 230 and it still doesn't turn the cooling fans on, then we've got a circuit problem which I'm going to have to fix. Alright, so our gauge is starting to come down. We are at 133. And our gauge is starting to fall. Okay, so the gauge has suffered a massive damage. This much I can tell you. Okay. We're going to cool our switch down a little bit with some water. That should make it fall a lot. It's slow reacting. Now our gauge is showing 210 and our actual temperature is 117. I think we might have a bad switch. All right, we'll cool it down a little bit more. Get it down to under 100 and see what the gauge does. All right, so our gauge is almost back down under 100 and we're at 97 degrees. All right, so now we're going to heat it up to about 200 and we're going to see what happens. Alright guys, we're down to 90 degrees and our gauge is sitting at 100, so I'm going to turn this off for just a moment. I'll be right back. Alright, we're back to 81 degrees on our temp sensor. We're switching over to butane. Butane will make this thing go a little bit faster. So we're going to light this up. We're going to get it up to about 212 and we're going to see if we can hear the cooling fans kick on. So, stand by. Climbing 131. Our gauge is, oh, okay, so we got a glitch in our gauge. It gets up to a certain point and then falls off. Goes back to 0. I think we got a bad gauge. Part of the problem. Up to 142. Gauge is tweaking on the end there. Where are we at? 163. $185. Okay, about 195 is when the thermostat opens. All right, 196, 194. All right, we've hit 212, so we've hit boiling point. We'll get it up to about 220, and then we're going to let it go because that's about when the cooling fan should kick on. All right, we're at 228. We're going to shut it down. Right now, the cooling fan should be on. Cooling fan should be on right now, and they're not on. I'm going to warm it up some more. See if we can get that thing up to about 230. All right, now the cooling fans should be on and they're not on. I'll show you our gauge as this thing falls. I'll zoom back so we can show you the gauge. This is what the gauge is doing. See, the gauge right there is all the way back to 260. It'll stay that way until it gets colder. That thing's at max right there. Possibly a bad switch. Okay, so I think I know our next course of action. Normally the cooling fans would be on, but I think the engine has to be running for that to happen. So it looks like we may have another bad switch. So I'll go get another one and we'll change it out. So to do this experiment, it's better if you have a cup of boiling water. You take the tip right there and you put it in the boiling water. Then if you have a scan tool or a thermometer, you can, like if I had used my infrared thermometer that I bought today, I could put it right there on this tip right here and compare that to what I'm getting on my scan tool, and that would tell me whether or not the computer and the heat off of this are correct. If there's a 10-degree difference between this and my scan tool, that would indicate that the resistor that sits inside here is bad, in which case you would go ahead and replace the switch. So being that we don't have cooling fans, I need to check the wiring going from the switch to the box, which I will do off camera. And there you go. Not exactly what I was going to have for today, but it worked out nonetheless. Another thing you want to do is, if you have a borescope, you can get down into the hole down there and put the borescope down inside there and look both ways and make sure you don't have any obstructions. If you have no obstructions, then you should be you'll be fine, because sometimes you'll get dirt or something that gets trapped down in there and it'll ground out the switch, and then you have another problem, so you have to flush your system out. But other than that, so that'll do it for this one. Unfortunately, we didn't get our cooling fans to come on. We had it up as high as 241 degrees, which is way too hot for this car anyway. So I'll figure it out, and if you want to know an update, comment down below and I'll post an update. So we'll see you on the next one. So I want to show you something. Scan tool says 190. By now your gauge would have pegged. Look at your gauge. Your gauge is working again. I'm hoping this is positive for future things, because we're going to see if the cooling fans kick on, but I wanted to show that to you. So I'm going through and editing the video that I did on showing you how to test for a bad circuit. And the problem ended up being the coolant temp sensor. I used a Master Pro sensor, which is the O'Reilly house brand, and I put 2 of those in it, and both of them were no good. Third sensor I put in was a standard sensor, which I've been finding lately to be OE quality. That one actually was a AC Delco that was in the box. The part number, I believe, was TX66 if you need one. Put that in the car. The gauge is off about 10 to 15 degrees. But the cooling fans kicked on at 227 and then shut down at 217 or 207. It was 207. Shut off at 207. And her gauge works fine. She's driving it now. Everything's great. So, lesson here is, don't go cheap on your sensors. It's best if you spend the extra 10 or 20 bucks and get the good quality ones, especially on these newer cars where the sensors, the resistance value is so tight that the aftermarket, like the house brand, that could have been a Duralast sensor or it could have been a CarQuest sensor, and it probably would have read wrong. So it's no slight against O'Reilly, because I use them a lot, but I've had this issue before with other sensors. So just thought I'd pop this little update at the end, and we'll see you on the next one.